Uh, there's like different classes. There's many different types of robots. So the giant robot that we saw lifting the car is like that is a catalog item.
Elon Musk has revealed a brand new Tesla assembly line, and it's unlike anything the company has built before. There are almost no human workers involved. Instead, robots handle nearly the entire production process. This is the Cybercab production line, built for Tesla's next-generation vehicle. You've probably seen Elon Musk walking through Tesla factories, proudly showing how cars are assembled at incredible speed. But this latest reveal isn't just another upgrade. It could completely change the way the auto industry thinks about manufacturing. According to Musk, Tesla's goal is to build a complete car in as little as 40 seconds. For more than a century, car manufacturers have followed the same basic process. Thousands of individual parts are made separately, welded together by large groups of robots, and then assembled piece by thousands of workers until a finished vehicle leaves the factory. That system has remained almost unchanged for generations. Tesla, however, is preparing to replace that traditional approach. Elon Musk isn't just focused on building the best electric car. He's focused on creating the world's most efficient factory. He believes that if manufacturing becomes much faster and cheaper, every vehicle automatically becomes less expensive to produce. When that happens, success won't depend on eye-catching designs or massive advertising budgets. It will belong to the company that builds cars most efficiently. So what is Tesla doing inside its Gigafactories? Why does Musk believe this manufacturing revolution could leave traditional automakers struggling to keep up? And most importantly, how can an entire Tesla really be built in only 40 seconds? For decades, the world's largest car companies have followed the same formula. A vehicle is divided into hundreds or even thousands of individual parts. Each part is produced separately, then welded, bolted, assembled, and inspected until everything comes together as one finished car. Companies like Toyota, Volkswagen, Ford, and General Motors have refined this process over many years, but the overall method has stayed largely the same. Elon Musk challenged one assumption that few others questioned. If dozens of small parts are always combined into one larger structure, why not create that entire section as a single piece from the beginning? That simple idea may become one of the biggest manufacturing breakthroughs in Tesla's history. Instead of joining dozens of stamped metal panels to build a vehicle's frame, Tesla uses massive casting machines known as the Giga Press. These machines generate between 6,000 and 9,000 tons of clamping force, while future versions are expected to reach an incredible 50,000 tons, potentially transforming the way cars are built. The Giga Press pours molten aluminum into a mold and creates a huge one-piece casting in a single cycle. As a result, dozens of separate components and hundreds of welds are eliminated. While this may seem like a small engineering improvement, its impact extends throughout the entire factory. With far fewer parts to assemble, Tesla no longer needs endless rows of welding robots. At Gigafactory, Texas, more than 1,000 robotic arms were once required to build vehicle frames. After the Giga Press was introduced, nearly half of those welding robots became unnecessary. Using fewer parts also means fewer weak points, fewer production mistakes, and a much simpler manufacturing process. This allows Tesla to build vehicles faster, reduce production costs, and produce cars at a pace that many traditional automakers find difficult to match. Most customers will never notice this change, but every second saved on the production line and every robot removed from the process helps lower the cost of the vehicle. Even more interesting, the Giga Press is not Tesla's final goal. It's only the beginning. Based on the company's recent presentations, Elon Musk is already working toward an even bigger innovation called the Unboxed Process, a manufacturing system that could completely reshape car production. Tesla now wants to challenge another long-standing industry practice. Instead of moving every car through one long assembly line where each part is added step by step, the company plans to divide the vehicle into 6 major modules. The front section can be built in one area, the rear body in another, the battery pack on its own production line, while the interior is assembled simultaneously in a different part of the factory. Tesla says this new manufacturing system could reduce production costs by 50%, shrink factory floor space by 40%, and improve overall efficiency and output by another 30%. But the most important figure is the 50% drop in manufacturing costs. By removing production bottlenecks, keeping robots operating more efficiently, and simplifying labor-heavy tasks like painting and final assembly, Tesla believes it can cut the cost of building its next-generation vehicles in half. If that becomes reality, Tesla's biggest innovation won't just be another electric car, it will be a completely new way of building one. The first vehicle expected to showcase this manufacturing strategy is the Cybercab. According to Elon Musk, Tesla aims to lower production costs to around $30,000 per vehicle, with even greater savings expected as the system improves and reaches full-scale production. Together, the Giga Press and the Unboxed Process represent Tesla's vision for the future of car manufacturing. One is already changing how vehicle structures are built, while the other is still being refined behind the scenes. If everything goes according to plan, Tesla expects the Unboxed system to enter high-volume production around 2027. But producing giant one-piece castings is only the first step. After leaving the Giga Press, these large aluminum sections move to the body shop, where they're transformed into the strong framework of a complete vehicle. Many engineers consider this the true heart of a Tesla factory. It's also where automation reaches another level. Unlike final assembly, where people and robots work together, the body shop is almost entirely run by machines. Hundreds of robotic arms operate around the clock, carrying out thousands of highly precise tasks with remarkable speed and accuracy. Every few seconds, thousands of welds are completed as another vehicle frame takes shape. Watching this process makes it clear why Elon Musk once described a Tesla factory as the machine that builds the machine. Every robot, every movement, and every operation is carefully timed and coordinated. But welding is only one part of the process. Once each component is in place, Tesla doesn't rely on a single joining method. Instead, it combines several advanced techniques, each designed for a specific purpose. Resistant spot welding secures the body with thousands of welds at the vehicle's most critical structural points. Where maximum precision is required, laser welding takes over, creating cleaner, stronger joints with a smooth finish. Tesla also applies high-strength structural adhesives throughout the body, bonding major sections together while increasing rigidity and reducing vibration and road noise. By combining advanced welding methods with aerospace-grade bonding materials, Tesla creates a body that's lighter, stronger, and more refined than one built with traditional welding alone. This is one reason Tesla vehicles consistently receive some of the highest crash safety ratings. A stronger and more rigid passenger compartment is better able to absorb and distribute crash forces before they reach the occupants. But speed isn't the only advantage robots provide. Consistency is just as important. Even the most skilled technician can produce excellent work, but after hours of repetitive tasks, small variations are unavoidable. Robots don't face that challenge. They can repeat the exact same movement thousands of times with nearly perfect accuracy. That consistency ensures every vehicle body leaving the body shop is built to the same high standard, creating the ideal foundation for the next stages of production. It's also why Tesla continues investing heavily in factory automation. Wherever machines can deliver greater precision and consistency than humans, Elon Musk wants robots handling the work. Even so, the vehicle is still far from complete. From the body shop, each car moves to one of the factory's most advanced and demanding areas, the paint shop. This is a place where perfection is essential. A single microscopic dust particle can ruin the paint, forcing the entire body to be repainted. That's why every stage of the painting process takes place in a tightly controlled environment, where temperature, humidity, and even air cleanliness are carefully monitored to ensure every Tesla leaves the factory with a flawless finish. Before the final paint is applied, the entire body goes through a thorough cleaning process. Every trace of dust, grease, and microscopic contamination from manufacturing must be removed, because even the smallest flaw can appear in the finished paint. The next stage is one of the factory's most important yet least recognized processes: electrophoretic deposition, better known as e-coating. Instead of spraying on a protective coating, Tesla submerges the entire vehicle body into a specialized chemical bath. This process allows the anti-corrosion layer to reach every exposed metal surface, even deep inside areas that spray systems can't access. That invisible coating becomes the car's first line of defense against moisture, road salt, and corrosion for years to come. Once the anti-corrosion coating is complete, the body receives a layer of primer, creating the ideal base for the exterior finish. Only then do Tesla's robotic paint systems apply the color coat, followed by a clear protective layer that seals everything underneath. Just like the body shop, almost every step in the paint shop is fully automated. Robots precisely control the thickness of each paint layer, ensuring a smooth and even finish across the entire vehicle. The freshly painted body then enters a large curing oven, where carefully controlled temperatures harden the paint into a durable, glossy surface designed to withstand years of sunlight, rain, heat, and harsh weather. Here's something most people don't know. The paint shop is one of the few areas inside a Tesla factory where different vehicle models move through the same production line. Only after painting is complete do they separate and continue to their own dedicated final assembly lines. The Cybertruck could become the first Tesla to skip one of the most expensive stages of vehicle production altogether. Instead of sending the finished body through a traditional paint shop, Tesla plans to build the color and protective finish directly into the large castings. If successful, it could eliminate an entire manufacturing department that automakers have depended on for decades. That's exactly why Tesla's manufacturing strategy is so important. The EV race is no longer just about longer driving range or faster acceleration. The real battle is taking place inside the factory. The company that can build vehicles at the lowest cost gains the ability to lower prices, attract more customers, and invest even more in future technology. Tesla has already shown how valuable that advantage can be. The company has repeatedly reduced vehicle prices across global markets, forcing competitors to respond while putting pressure on their own profit margins. If Tesla's next-generation manufacturing system performs as expected, the cost gap between Tesla and traditional automakers could become even wider. But there's one important lesson many people overlook. Despite being one of the biggest supporters of factory automation, Elon Musk once relied too heavily on robots, leading to one of Tesla's biggest manufacturing setbacks. In 2018, while increasing Model 3 production, Musk pushed automation to its limits in an effort to reach 5,000 vehicles per week. However, many robots struggled with complex jobs such as handling wiring and flexible materials, causing repeated production delays. Musk later admitted the approach had been a mistake, famously saying, "Excessive automation at Tesla was a mistake. Humans are underrated." That experience changed Tesla's manufacturing strategy. Instead of automating every task, Tesla now uses robots only where they clearly outperform people, while leaving jobs that require flexibility and adaptability to human workers. The goal is no longer maximum automation, it's maximum efficiency. During the Model 3 production ramp, Elon Musk believed adding more robots would naturally make Tesla's factories faster and more efficient. Instead, equipment failures and production bottlenecks repeatedly slowed production, proving that robots couldn't replace people in every situation. Musk later acknowledged that he had overestimated automation and underestimated human adaptability. That costly lesson reshaped Tesla's manufacturing philosophy. Today, the company focuses on using robots where they perform best, and people where human skills offer the greatest advantage, all with one objective: building vehicles as efficiently as possible. And that's it for today's episode. If you enjoyed this look at how Tesla is transforming the future of manufacturing, don't forget to like the video, subscribe to the channel, and turn on notifications so you don't miss our next upload. We'll be back soon with more stories about innovative engineering and the technologies shaping tomorrow. Thanks for watching, and we'll see you in the next video.